Hello, Dr. Martin again, and General Biology 1114 at Rogers State University. Coming to talk to you today about Chapter 39 in our text. We are really close to the end of this semester. In fact, after this lecture, there's only one more lecture next week. So we're nearing the end of this. So I encourage you to stay plugged in, take good notes. Be really diligent to meet your deadlines on your assignments this week. There's 2 labs. There's also 2 quizzes. There's 2 smart books. So we kind of ramp up a little bit this week. And so be real attentive to completing your assignments. You're doing a really good job on your assignments. And just be real attentive to those due dates, especially here at the end. We don't want to lose points just because we missed a deadline or something. So let's finish up here with chapter 39. And if you remember, we are going through the hierarchy of ecological levels of hierarchy or levels of organization, starting with an organism and groups of organisms of the same species in a certain area are populations. Populations comprise bigger and broader and wider areas that we call communities, multiple populations in a certain area, ecosystems, multiple populations, including the abiotic environment. And now we're at an even higher level of ecological hierarchy, and that's biomes. Biomes are large areas of the earth that are dominated by we used to say this, they're dominated by a specific plant type: tropical rainforests, deciduous forests, coniferous forests, tundra, desert, grasslands, dominated by certain species. But we also know that they are impacted by soil composition. And so, in fact, we now call this physiography. It's a combination of geography and physiology, and it's why certain plants are where they are found in on the earth. So these are what we call biomes: large, complex systems that are dominated by generally a similar plant type or particular species composition. All of these biomes, at the most basic level, they have primary producers that produce energy. Usually, sunlight is the ultimate energy for all biomes on Earth, but primary producers, plants primarily, are the ones that take this sunlight, you know this, convert it into usable glucose, and then that supports all other life on Earth. We call these primary producers. In fact, we call that primary production. And we classify biomes oftentimes on how good they are at producing. We call those primary producers or primary production. You can, in your mind, you can identify which you think are the biomes that are the greatest at primary production. They produce the most amount of oxygen, nutrients, and tropical rainforest, one of the highest, oceans, probably the highest, and then deserts, Arctic regions, Antarctic regions, probably the lowest. And so we call this primary production. That's how we kind of rank biomes. There's a lot of abiotic factors that influence species compositions of biomes. Light, we've already talked about, moisture, temperature. In fact, if we were to rank the abiotic factors that influence biomes and diversity on Earth, probably moisture. Probably the number one influencer of primary production on the Earth is moisture. Temperature is another one, extremes in temperature, then nutrient availability, oxygen, and things like that. All of those are abiotic factors that influence plant life of biomes. Differences in climate are impacted by abiotic factors. Look here, the cooler regions are in blue, warmer regions are in red, and then intermediate levels in greens and yellows. You can kind of see the warmth here. along the equator. That's not going to be anything new to you. Along the equator, 0 degrees latitude is where we have our warmest climates, warmest and moistest climates as well. As we move away from the poles, north and south, greater variations begin to occur. Colder climates begin to occur as well as we increase in latitude away from 0 degrees. And there's a lot of factors we get. Seasonality impacts climate. The tilt of the Earth's axis, you know this, as it moves around the sun, that's what creates our seasons, spring, fall. We're kind of in what we call equinox right now, where it's rather an equal amount of sunlight. But as we move closer to the summer, okay, we move a little closer to this, or get a little bit more of a sunlight because of our tilt versus the southern hemisphere. One of the craziest things I've ever done, and maybe you've noticed too, is I was in Brazil one year on a mission trip, and I was on the south side of a building in the shade in the middle of the day. Now think about that. I was on the south side of a building in the shade on a sunny day. That is completely the opposite of the northern hemisphere where you and I live. Here, if you want a shady patio, well, you face it to the north, and it was the opposite of that. And it kind of struck me that southern hemisphere, northern hemisphere are completely the opposites in shade versus sun in their structures. But seasonality produces differences and creates winter versus summer. Um, uh, Air circulation. We don't often think of this, but air circulation creates ocean current circulations, and these impact climate as well and biome distributions as well. Look here with my cursor. So the Earth rotates this way, but air at the equator tends to rise because hot air rises. Now it looks like it's going to the side here, but that's people don't stand on their head at the equator, but warm air tends to rise along the equator. The closer to 0 degrees latitude, the more warm the temperatures. As the air rises, the Earth rotates underneath that air, and it creates air currents. That influences climate. It also influences water currents. And we tend to have a lot of tropical rainforests here along the 0 degrees along the equator, and so that's the warmest, moistest climates right here. A lot of deserts occur in these mid levels here, usually along 30 degrees north and south. And there's some reasons for that. But air currents influence climate. Mid latitudes are impacted, but also ocean currents are impacted as well. Remember, we said here along the equator, 0 degrees latitude, air tends to rise and the Earth rotates underneath it. So what happens is these currents hit these land masses and they tend to move like this. And in the northern hemisphere, ocean currents move in a clockwise rotation. In the southern hemisphere, they move in a counterclockwise rotation. And that, as these currents hit land masses, storm systems move in this direction. In North America, most of our storm systems, this, come from the northwest or the southwest. Well, air currents influence ocean currents. Ocean currents influence biomes. And so all of these are abiotic factors. Mountains influence If you've ever lived in the along the Pacific coast from Oregon, British Columbia, all the way down to Baja, California, you know how these fronts that tend to move from west to east, they get air currents that are forced up and into the atmosphere, and these air currents, precipitation tends to fall on what we call the windward side of these mountains. And by the time they get over the mountain, these fronts are depleted of moisture, and we have extremely arid conditions on leeward side of mountain ranges. And we get this all along the western coast of the United States. It's why we have really nice conditions sometimes on the windward side, especially in Washington and Oregon. But on the other side, Washington State is one of the most extreme differences between climate in the state of Washington. Really semi-tropical climates on the western side of the mountain ranges in the state of Washington, and within literally just 100 miles, extreme deserts in the eastern portion of the state of Washington. Oregon is the same way. But this is what we call the rain shadow effect. So even mountain ranges impact climates. Well, let's talk about these biomes then. Large systems comprised of multiple ecosystems, multiple communities, and we tend to classify them into really just about 7 or 8 very specific biomes. Ones that are on land, hard land, we call terrestrial biomes. If it's water, we call them aquatic biomes. And they have distinctive communities. They have very distinctive temperature, moisture, and vegetation, but they're pretty distinctive. So let's walk through these terrestrial biomes first. The most common that we often like to talk about is the tropical rainforest, the most diverse systems on the planet. Look where they occur. All of these are in green here. They occur between the 2 tropic lines, the Tropic of Cancer, the Tropic of Capricorn. They are about 23.5 degrees north and 23.5 degrees south, north here, south here. This is our tropic region. Look at these. Look how much Earth is dominated in these tropical zones here. Now, tropical rainforests don't occupy a lot of the terrestrial planet, but between these tropic lines, they occupy a lot of the terrestrial land masses between these tropic zones. That's where we find most of the very warm, very wet, highly diverse, multiple species of plants, animal, fungus, bacteria, highest and most diverse regions on the terrestrial Earth are the tropical rainforest. Highly productive. Also highly threatened, as you might suspect. The greatest threat to our biomes is human population growth. We've talked about that before. In these regions here, especially in Indonesia and also South America, the greatest threat is the use of these forests for heating and cooking. Not so much deforestation for wood products, mostly for heating and cooking. That's what the highest rate of deforestation is causing in these tropic zones, because some of these areas are also some of the highest population growth regions, especially Indonesia, in the world. Palm oil production is becoming quite serious for deforestation and conversion to agriculture in these regions, especially Indonesia. Agriculturally grown palm oils, which is found in almost every product you purchase at the grocery store. So tropical rainforests, very productive, highly diverse, and also highly threatened of all of these biomes. Whereas temperate forests are kind of like the forests that you live in Oklahoma. If you live east of Tulsa, northeast of Tulsa. These are what we call temperate forests. We live in what we call temperate deciduous forests. Remember what deciduous means? Deciduous teeth. You lose different sets of teeth. Deciduous trees lose their leaves based on seasons. And so we have temperate deciduous forests. You live and I lived in eastern Oklahoma in what we call temperate deciduous forests. There's also some temperate coniferous forests where the forest is comprised of coniferous trees, pines, firs, spruces, evergreens like that. But these are what we call temperate forests. And look right here, they usually lie between 30 and 60 degrees north latitude. So here's 23 and a half or 30 degrees, and then up here in the Arctic Circle is 66 and a half degrees, the Arctic Circle and the Antarctic Circle. That's where we find most of our temperate forests. In North America, we have mostly temperate forests, East Coast to West Coast. Don't be fooled. You hear a lot of information about the temperate forests in North America and deforestation in North America. We probably have more forested landscapes in North America now than we have since European settlement. Probably more forest now. Now, don't be fooled though. Most of those forests are secondary forests. They're not primary forests. There's very little old growth primary forests remaining in North America. Most of it's been cut. Even the forests in eastern Oklahoma, they've been cut in the last 100 years, last 150 years. So what you're not seeing is primary forest. Southern United States, the pine regrowth in the southern United States mostly replaced cotton plantations in the southern United States. And so a lot of forestation has occurred in the southern United States. A lot of reforestation has occurred in the northeastern New England states. So we probably have more forests in North America than we have since European settlement. But it is a little different composition of forest than what the European settlers encountered when they first arrived here. But these are, in North America, what we call temperate forests. The taiga is a very unique forest system, or what we call boreal forests, mostly very hard. Look where they're located here, above and along and above 60 degrees north. 66 and a half degrees north is the Arctic Circle, and that's where we find most of, look at across the continent of Asia and Europe, Norway, Sweden, Russia. We see these large boreal forests. Canada, mostly large boreal forests. Most of these are evergreen trees, spruce, fir, pines, but very harsh climates, but very conducive to the growth of large trees. But this is what we call the taiga or boreal forest. Taiga is kind of a Russian term for taiga. Temperate grasslands west of Tulsa, basically west all the way to the Colorado Rocky Mountains. This is where we see the vast grasslands of North America in particular. Now, grasslands are not just limited to North America. We see them in South America. We see them in Southern Africa, what we call the veld. We see them in Europe, what we call the steppes. In South America, they're called the pampa. So we see grasslands on almost every continent, but we are most familiar with them in you don't have to drive very far north of Tulsa, the Osage County. It's classic temperate grasslands. In North America, we have tall grass prairies, we have mixed grass prairies, and then we have short grass prairies. And most of our tall grass is gone. Much of our mixed grass is gone. The one biome that's remaining the most is probably short grass prairie. If you ever drive to Colorado and you go up to Wichita and head west, You drive through that shortgrass prairie, and it's a beautiful prairie in Central America and in the plains. But this is the temperate grasslands, dominated by grasses, and fewer trees the west that you go. Desert environments. I love desert environments. I live in a desert environment now. Very low precip rates. Remember last chapter we talked about very high evap rates, lower precip rates, high evaporation rates in these deserts. Um, Generally found along the 30-degree north and south. Look right here. Here's the 23.5 degrees or about 30 degrees north, 30 degrees south. This is where we see most of our continental deserts. Um, Very low vegetation rates. Where I live, the plants are far apart. The plants are short. Plants tend to be dominated by only a certain few families. You know this, cacti, maybe some grasses, but sometimes they're cold, sometimes they're hot, but they receive less than 20 centimeters of rain a year, which is about 10 inches roughly of rain a year. There in Tulsa area, Claremore area, you receive about 47 inches of rain a year, about 8 inches of rain here where I live in far western Colorado, almost Utah. But the diversity of life in these deserts can surprise you. Birds, bats, reptiles, pretty highly diverse, mammals, pretty highly diverse in these desert areas. And so they can be more productive than you might think in these desert environments. Also extreme heat usually in these areas as well. We don't often hear of the Mediterranean climates. If you've ever lived in a Mediterranean climate, it is beautiful. I never have, but I've visited Mediterranean climates. In North America, about the only area we can identify as a Mediterranean climate is Southern California, the coast, not very far inland. If you've ever visited San Diego before, you know what I'm talking about. I was in San Diego one year in the middle of January. It was 2 or 3 degrees in Tulsa and Claremore. And I was in sunny San Diego where it was 80, 85 degrees. Beautiful climates. Not very extreme variations seasonally. Moderate amounts of rainfall, but not much. Moderate temperatures. But these are Mediterranean climates. Look around the Mediterranean rim here, and if you've ever traveled to Rome or Italy or Spain or Greece, southern France, you know these Mediterranean climates. Dry, pleasant, don't really have extreme seasonal changes. They also tend to be very, very productive. Species that grow here tend to grow here and nowhere else in the world. So a lot of threats to Mediterranean climates, as you would suspect. One of the fastest growing metropolitan areas in the country is the San Diego area. Again, around the Mediterranean rim, fast growing population centers. So these habitats, Mediterranean habitats, they support some pretty unique species, but they're also highly threatened because of population growth. It's what we call Mediterranean climates. And then there's tundra, very cold, very extreme environments. They tend to be along very extreme northern latitudes. These are the tundra biome, short growing seasons, short plants, pretty limited species, tend to be very sensitive to change, very sensitive to human encroachment because there's not a lot of fast regrowth of vegetation. So if you damage the vegetation, the impact lasts longer. Usually they have a lot of permafrost where the ground is frozen several inches, several feet even below surface. There's some places here in Colorado up in an altitude where they have to bury their water lines, gas lines about sometimes 10 foot deep. because the permafrost will reach that far down in the wintertime. So tundra, very, very limited plant life, very limited growing seasons, very little rebound, not a very quick rebound after disturbance. And but this is the tundra. Usually we call it Arctic tundra. And then there's polar ice, very extreme. Antarctica is a classic example here. Very little plant life, very little support for, except along the coastlines for marine life or aquatic life. This is the polar ice regions of Antarctica. We don't often think of water as a biome, but it is. First of all, there's freshwater biomes. We distinguish between saltwater, freshwater. Freshwater biomes cover, well, this is a really good illustration on the far right here. If we had a swimming pool that represents oceanic saltwater, what we call marine systems, they occupy about 97% of all water on Earth is salt water. 97% of all water on Earth is salt water. That only leaves about 3% of the Earth's water for you and I and all other plant and animal life terrestrially. So of that 3% of fresh water, most of it, 2%, is found in polar ice caps and in glaciers. So that only leaves about 1% of the Earth's water for you and I to consume. Much of that is groundwater. Much of that 1% is groundwater found in underground aquifers. The Ogallala Aquifer in the Central Plains region is one of those. Some of it is in soil. And here's about how much is remaining for you and I to consume. The amount of surface water globally that we can consume, a very, very small amount, relatively speaking. So it's a very limited, very sensitive source for you and I. Living in the Western United States, I hear about this quite often because you in Oklahoma, eastern Oklahoma, after about 6 inches of rain, probably recently, you're not thinking about depletion of water resources. But in the Western United States, very extremely high population centers in the Western United States. We talked about San Diego. One of the other fastest growing urbanization centers in the United States is Las Vegas. And so Las Vegas and San Diego depend primarily on the same water source, and that is the Colorado River. A lot of controversy in the Western United States about the use of water from the Colorado River. So that's fresh lakes and ponds. Usually, if we try to define the difference between freshwater lakes, freshwater ponds, is lakes. Lakes are larger, maybe a little larger. Ponds tend to be a little smaller. Here in Colorado, we have some lakes here that in eastern Oklahoma you would call them ponds, but we call them lakes here. Generally speaking, a pond has rooted aquatic plants across the bottom. Lakes are a little bit bigger, a little deeper, and they don't have aquatic plants all the way across the bottom. But there's a lot of different classifications between lakes and ponds. More than that is we classify lakes based on the type of plant life they support. Oligotrophic, trophic meaning energy, trophic meaning food. Oligotrophic lakes are very nutrient poor. They tend to be very clear, very pretty. You can see very deep. They tend to be young lakes, but those are what we call oligotrophic lakes. They're kind of poor nutrient, poor growth, poor plankton support, microscopic animal and plant support, and therefore just simply not much in them. They're very beautiful, very blue, very clear, but they're oligotrophic lakes, very low nutrient source, whereas eutrophic lakes or ponds tend to be more highly productive. They have more nutrients, more plant life, more animal life, more oxygen, and those are eutrophic lakes versus oligotrophic lakes, based on the kind of nutrient value and plant and animal life they produce. But oceans, I know we're kind of landlocked in Oklahoma, but oceans, wow, 70% of the Earth's surface is covered by saltwater oceans. Um, the depth is remarkable. The life that is supported here is remarkable. We've talked about this. Most photosynthesis on Earth occurs in the oceans. The highest amount of oxygen production into the atmosphere is by algae, oceanic algae, not necessarily tropical rainforest. So very important system, vast system. 70% of the Earth is covered by salt water. Some of the highest, richest productive areas on the globe are what we call estuaries, and these are mixtures of salt water, fresh water. It's where they meet: the Mississippi Delta, the Amazon Delta, the Nile Delta, the Yangtze Delta. All of these are regions where there's a mixture of saltwater, freshwater. The Columbia Basin in Oregon and Washington, the Columbia River Delta. These estuaries, very nutrient rich. You get the flow from a river into the ocean, and you just get a very rich and highly productive area. Organisms that live here, they have to have a pretty high tolerance level of saltwater, non-saltwater, saltwater, freshwater mix, and they have to be able to manage that kind of environment. Kind of extreme, but very productive. Look at this last, very productive ecosystems in these estuaries. Intertidal zones, where continental shelf meets oceanic waters. If you've ever traveled to the coast, you know what we're talking about. It's the periodic uncovering of water. Tidal zones, very pretty extreme zones. If you're going to be an organism living in this kind of an environment, you have to be a pretty tough critter, plant or animal, periodically covered by water, periodically uncovered by water. Now, think about the temperature that they have to, the temperature extremes that they have to be able to live. Tropics, not a big deal, but you get away from the tropics, the temperature swings between being covered by water and warmth, uncovered by water and cold, very extreme environments. And organisms that live in these environments are highly adapted to those specific environments in intertidal zones. Hey, just one more slide here. Coral reefs, again, one of those biomes that's highly productive. I've only dove in a few coral reef areas, just highly productive of plant life, animal life. Corals are animals, they're not plants. We learned that earlier in the semester. But a lot of calcium carbonate built up over thousands of years. But anyway, these are coral reefs and highly, highly productive. One of which is the Great Barrier Reef off the east coast of Australia. One of the few living systems that can literally be viewed from space. Large, highly productive areas. So hey, let's end there. We could talk about this forever, and I don't want to do that. I want to be conscious of your time. But this is chapter 9 on biomes. Remember, we classified them into separate terrestrial and aquatic biomes. There's really only 2 aquatic biomes, and that's freshwater and saltwater. But there's multiple terrestrial biomes. Know each one, know the key characteristics of each one, and we'll finish this lecture right here. But have a good week. Enjoy these 2 chapters, chapter 38 and 39 this week.